Welcome to this explainer. We're jumping right into the hidden engine powering modern cloud computing today. If you've ever, just marveled at how massively complex digital infrastructures manage to stay perfectly synchronized and continuously online, well, you're in exactly the right place. Today, we're demystifying etcd, a foundational technology that's basically the absolute bedrock, the ultimate memory of distributed systems.
So, I want to pose a question directly to all you IT students and cloud enthusiasts watching right now. How do massive cloud systems never lose their memory? Think about it for a second. In a sprawling cloud environment, servers inevitably fail, right? Network cables get unplugged, hardware degrades, it happens. Yet the overall application just keeps running flawlessly without forgetting its configurations or losing its place. So what actually happens when those parts go offline? Well, the answer lies in how these systems handle their most vital data, and that's exactly what we're going to unpack right now.
Here's our roadmap for today. We're going to start with the core concept, look at the architecture under the hood, explore primary etcd use cases, see how it powers Kubernetes clusters, and finish up with what's new in version 3.7.
All right, let's kick things off with Section 1, the core concept.
To really wrap your head around this, just imagine a massive public library. To find absolutely anything in there, you rely on a centralized catalog, right? It knows exactly where every single book is stored, who is it checked out, and what specific section it belongs to. Well, etcd plays that exact same role, but for distributed application. Instead of tracking paperbacks, it manages and tracks all the vital, centralized configuration data for your entire network of computers. It's the ultimate source of truth.
So at its core, etcd is a distributed key value store. It's engineered from the ground up to be highly available and completely fault-tolerant. Listen, in cloud orchestration, you literally cannot afford for your library catalog to just disappear. etcd ensures that even if parts of your system suddenly crash or go offline, the critical data required to keep everything running remains completely reliable and instantly accessible.
Moving right along to Section 2, architecture under the hood.
Let's actually see this fault tolerance in action. When data enters your system, it doesn't just sit on one vulnerable machine. No way. Instead, etcd immediately replicates that data across multiple nodes. Think back to our librarians for a second. If one of them calls in sick, the library doesn't shut down because the others have the exact same catalog. Because the data is replicated, it remains highly available. So even if several nodes crash entirely, your system stays online and your data is absolutely safe.
Now let's dive into Section 3, primary etcd use cases.
So, what's actually inside etcd's core toolkit? First up, we've got service discovery. In a highly dynamic cloud where services are constantly spinning up and shutting down, etcd acts as the locator, making sure different parts of the application can always find each other. Second, distributed locking. Look, when multiple parts of a system try to change the exact same data simultaneously, you are risking absolute chaos. etcd provides the locks to prevent those nasty data conflicts, ensuring only one process modifies data at a time. And finally, configuration management. It centrally manages all your application settings. Together, these three operations are absolutely crucial for keeping complex distributed applications perfectly synced up.
All right, shifting gears to Section 4, powering Kubernetes clusters.
We all know Kubernetes practically runs the modern web, right? But etcd is the one secretly doing all the heavy lifting behind the scenes. In Kubernetes, etcd stores and manages all the cluster configuration data. It tracks the exact number of deployment replicas you've requested. It keeps a super strict record of all your container ports. It handles the service discovery tracking and those vital distributed locking mechanisms we literally just talked about. Basically, it maintains the absolute desired state of your entire cluster, making sure reality always matches your instructions.
Put simply, etcd is the absolute brain of the Kubernetes cluster. Think of it like this. If Kubernetes is the nervous system coordinating all the movement, etcd is the memory. Without it, the cluster wouldn't know what applications to run, where to run them, or how they even connect. The whole thing would just completely cease to function. It's a total game changer.
Which brings us to Section 5, what's new in version 3.7.
As we know, software never stands still, and etcd is continually evolving. In the 3.7 beta, developers have seriously pushed the boundaries to deliver improved overall performance and enhanced system scalability. So what does that actually mean for us? It means handling way more data, way faster, across even larger clusters. They've also rolled out some fresh new features specifically targeting service discovery, alongside upgraded distributed locking capabilities. These updates are directly designed to empower IT professionals to build cloud architectures that are just more robust and scalable than ever before.
And that brings us to the end of this explainer. But before we wrap up, I want to leave you with a final challenge. How will you use etcd to build the next unbreakable distributed system? You now understand its core role as a highly available, fault-tolerant key-value store. You've seen exactly how its replicated architecture protects against total failure, and you know why it's the indispensable brain behind Kubernetes. Now? Well, now it's your turn to take this foundational knowledge and apply it to your own scalable cloud computing projects. Thank you so much for joining me to explore the memory of the cloud, and I honestly can't wait to see what you build next.